right? Sometimes, let's say in some position, we would like to send these offers to certain customers, but I want to know what is going to be the impact of it, right? In terms of benefit to my business. And I would like to, of course, send these, let's say, brochures to select customers only whom I believe will get this product. I mean, you could potentially send it to all, but let's say these are printed products, ads, so it is kind of expensive. You want to target them properly, right? In that case, we would be worried about two things. What is the false positive rate, right? So I'm gonna say these people will buy this product or loan when in fact they will not buy it, right? And then what percentage of people will really buy this thing? So I want to know that so I can target these customers, right? For that, I'm gonna import, like, to do some kind of a sensitivity analysis. I'm going to download metrics and then import ROC auction score that basically scores, and then same way I'm gonna get the curve. Right, and I'm gonna create a curve basically, right? So let's say Logit ROC auction is going to be equal to this ROC auction score. So it's gonna basically score what percentage of people are predicted correctly and so forth. Y validation data, right? Of course, I want to work with that one. And then I'm going to use Logit model that I created and predict that one with the X validation, right? So that way it doesn't really know. All right, the next thing is that for ROC curve, I'm gonna define a couple of things. FPR stands for false positive, and then true positive, TPR actually, true positive, and I'm gonna define a threshold, right? And I will use ROC curve. Hopefully when we have the curve, it's gonna be easier to explain it, right? Same way, I'm gonna use the validation data set, right? My Logit model, of course. Then I'm going to predict and then calculate the probabilities, right, for X validation data set. And once that is done, I'm gonna do it for all basically rows for the one column I have, in this case, right? So let's do this. Oops, I made some kind of a all right, it seems I had a typo here. Let's do it again. All right, so it's working. So next I'm gonna start plotting a figure. All right, and then I'm gonna say basically plot, right, and I'm going to add this FPR, TPR, right, and I'm gonna give a name for this one. I will say it is equal to Logit model, let's say 1, in case I want to develop another one. Area is equal to 2-digit accuracy, and I'll explain what that means. 2F, right? And then this Logit model, so I'm gonna use this one, right? And then close it. Next, I can just show all right. So this is the figure, but let me add some details. I guess that would help. Limits are okay. So I can say plot, add a label, X label, right, for the figure. And that is going to be false positive rate, right? And then I can add the plot Y label. This is true positive rate, right? All right, let's check. All right, so what does it mean? All right, basically it means if I want to accept 20, let's say, start here, 5% false positive rate, then I will get a total of almost 90% true positive. So if I want to go with that, that is a solution. If I target like 20% false positive, like I will get 20% of the people, I would think they will basically get the loan from me, and I adjust the probability such a way that in that case, I will also get almost 95% people getting that one, right? And then of course, if I'm willing to get to everybody, accept all the positive, false positive rates, then I will get all the people who will get this product as well, right? So the idea here is that we are playing with the probabilities. Let's say when I have logit model, I can say anything beyond 0.5 is positive, the person will get this loan, and then anything below that, it's not going to get it, right? And based on that, I will classify the observation, and then I'm looking at it, but then I could adjust it such a way that that probability or like 0.5, where I would end up with let's say 20% false positive, right? I would say these are actually will receive the loan, but in that case I would get the 95% of the right people as well, right? Or I might be more concerned. I could just say I don't want to send it to anybody who's not going to get this basically product, and then send it to, let's say, 10% or target 10% false positive rate. In that case, I will perhaps increase my 0.5 to 0.7, 0.8, and then I will only get like, let's say, 0.90, right? So that is kind of the trade-off. I could play with the probability where I assume it switches from will receive the loan or will get the loan to will not get the loan, and based on that, I will receive certain amount of false positives and true positives, right? So this is the idea basically behind this figure, right? And what we would like to do is make sure that we are choosing a point where we are comfortably getting most of the true positive rates, but then we are not really sending too many false positives. All right, so I added some more details to this figure we have, right? And by the way, I mentioned the area, and I'll said I'm going to explain it. Basically, what it says is this area under this curve is 81% of the results, right? So we are able to capture 81% of the true or the positive that will be classified correctly in this model, right? The next thing is that when we look into the stat model, you will see that we actually think certain parameters are not impacting model accuracy. Those are experience, age, and mortgage. So let's see if we can compare those two models and come up with a difference, right? So first thing is I'm going to define any variable, and I'm gonna just copy paste to save the time here. So I'm defining this x reduce, that is x vars all the columns except the personal loan, and I'm dropping columns of experience, age, and mortgage, right? And then I'm saying do it for all the column, and then defining an if training data set and validation data set. And I put the same number, so I am actually testing on the same exact validation data set. Next, I'm gonna define a new basically function again. This is logit model 2. Again, I'm using the logistic regression, but I'm fitting this new training data set based on the reduced number of columns. And I'm also defining this ROC auction and score values. And then basically I'm gonna do almost the same thing here. Call my figure. Actually, let me run this first. All right, and then I'm gonna have this one. So what I did is I just added 2 on all of them. So if I copy this line and add 2 right here, so I'm creating a figure based on this one, and then this is 2, right? And then draw the figure. All right, that's kind of small. Let me resize it. 10 square. Let's see. All right. So when I look into this one, first of all, the second model with the reduced number of columns also have less predictive capability. So it is decreasing by about 3%, right? And then the other thing is that in some areas, actually, the logit model 2 is better, right? For example, in this area, it seems it is better, but this is like not very significant if you really want to see it. And we could also calculate the difference and print that one out, but I just don't think it is a big value. So in this case, you have 2 choices. Like if you're really interested in this area, right? And let me actually say point. Right. You see, if I'm interested in this area, I can look into a little bit more in detail and read. Basically, actually, I could also change this one. I am trying to focus on that area, right? So in this area, I could see which one of them is better. So honestly, it doesn't look like they are very different. So I have 2 choices. One, again, I don't need much data or the same amount of data, but my accuracy is almost the same. This is parallel to what we discussed with the explanatory model. At that point, we also realized that these 3 columns were not adding a lot of value to my model. So I just agree with that, right? If I accidentally, let's say, instead of age, let's say drop income, right, and then do all this again, let's see what happens, right? If I do reduce drop the income rather than the age, it looks like the results are going to be significantly different, right? See, dropping income would have ended up with a worse result. When I accept, let's say, 20% false positive, accidentally sending to 20% of the people who would not get the product, I would also get less than 80%. But with this improved model, income included, at the 20%, I would be about 90-95% of the capturing 90-95% of those who wants to get this loan that I'm offering, right? So that is kind of important, but in this case, we were able to show that both models are good or they are not very different in terms of performing, whether I have age, experience, and mortgage in the calculation or not. So it is up to you. To me, if there is a data collection issue, I think experience could be one of them. How would you ask how many years of experience you have? I mean, it is easy to ask, like, how long have you been working in this company, the last place of employment, but it is kind of difficult to ask the overall years of experience to a person, right? So in this case, again, collecting less data might be okay, just because our explanatory power and predictive power are almost the same.